Good evening, students. How are you? By God's grace, I hope you are faring well. Yes. Now, I gave this as a test. I asked students to prove why the derivative of a constant is always zero, but most of them had zero. Are you okay? So I just want to use this as an opportunity to explain why, by proving it, why are we saying the derivative of a constant equals zero. So let's say if you have a function, let's say y equals any constant of your choice. So let's say I will choose my constant to be 4. You can decide to choose any constant of your choice. So I'll choose 4. 4 is what? The constant number. Now you know that according to indices or simply algebra, you know that y is equal to 4. The 4 in other words means 4x to the power of 0. Because you know that any non-zero number raised to the power 0 is equal to what? Like any non-zero number raised to the power 0 is what? It's 1. So as a result of that, I can say x to the power 0 is equal to 1. And the 1 will multiply the 4, and I'll still get back my 4. As a result of that, y is equal to 4 is the same as what? 4x to the power 0, provided this x is not equal to what? It's not equal to 0, non-zero. Are you okay? Now, I will say let y represent f of x. That's my function. Are you okay? So I will say let y be equal to f of x. Now to prove why the derivative of a constant is always 0, we prove that using differentiation from first principle. And differentiation from the first principle, we know the formula to be what? dy dx is equal to what? Lim as h approaches what? 0. Then we have f of x plus h minus f of x over h. So because I have f of x over here, that is why I'm saying let this y represent the function f of x. Are you okay? So now, so clearly I can say f of x, which is equal to y, is the same as what? 4x to the power what? 0. And from the formula, you know, for the formula, unless I figure out f of x plus h. Are you okay? So since I know f of x, let me find my f of x plus h. And now from the first principle, wherever you see x, add x plus h. Are you okay? So I'll also do some videos concerning differentiation from first principle, and you understand it better. So I have my 4. Now I have x here. So now wherever I see the x, I'll modify it to x plus h. The only difference is I'm adding h to the x. So here will be x plus h, and here it is to the power of 0. I'll also do that nicely. Are you okay? Now, what is the formula? I told you that I'll prove this using what? Differentiation from first principle. And you know that the formula is what? dy over dx, which is the same as what? F prime of x is equal to lim of the expression x plus h, the function that's f plus h, minus what? F of x, all on what? On h, as h approaches what? 0. This is the formula. So I'll just do my simple substitution. So let's see how it goes. So now my dy over dx finally become, I have f into bracket s plus h, right? So what is my f of s plus h? Clearly it is this. So I'll come write 4 into bracket x plus what? Plus h to the power what? 0. Then I have minus my f of x. My f of x here. Where is my f of x? My f of x here is what? Is 4 s to the power what? 0. All divided by what? By h. Then I have my dy dx to be equal to, you know that any non-zero number raised to the power 0 is equal to 1. So therefore, this is the same as what? 4. This expression together with the 0 will go to 1. So therefore, that's why I'm writing my 4 minus. The same also applies to the x to the power 0, which will give me 1. So I'll therefore maintain what? The 4 all over what? My h. So I'll come and get what? 4 minus 4 is what? 0 over what? Over h. So I have my dy over the x is equal to 0 over. No, now we are saying that as h approaches 0. So now wherever I see h, I'll put 0 there because we say h approaches 0. Are you okay? So here I have my h here. So here will be my 0 over the 0, which is equal to what? 0. That is why whenever you differentiate a constant, we equate it to what? To 0. Thank you. Meet you next time.